Hey guys, we're here tonight with, I still have my stuff up from last time. Delete, 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 eradicate. The machines are taking over. Oh, fun fact. My wife and I were talking about, at what point can we call coronavirus a plague? And it turns out a plague has to be biological in nature, so we never get to say that we survived a plague. I feel like we need a plague equivalent for a virus, Something just like a virus gone horribly out of whack. I don't know. You guys will have to tell me some ideas for that. Alright, viral calamity. Okay, so my name is Woo in the wrong color right now, because I'm going to write in blue. Key. And this is for 4-7. And this is Algebra 2. And this is 8.7 graphing rational. That's an O. Functions. Okay, and before I kick off, a couple announcements. The first one, I just forgot. One question. As we go through the class, I'm just like, oh, this is a hard topic, or this is an easy topic, or this is kind of in the middle, And one of the things that you guys have often asked me is, Mr. Frame, what do you think the hardest thing is in Algebra 2? And I've said to you, in my personal opinion, because I also find them difficult, it's combinatorials and permutations. Well, you will all be very sad to know that, as far as I know, that has been cut from this quarter for that week we lost. So you guys will not get to experience the joy of combinatorials and permutations. After we are done with rationals, it's going to be all trigonometry for the rest of the year, I think. Which, personally, I really don't like trigonometry. So I'm not happy about that. I was actually excited to talk about combinatorials and permutations with you guys. And I was hoping we could do some stuff with the normal distribution as well, and quantiles. But we won't get to do any of those fun things. It's just going to be trigonometry. So that's announcement 1. Announcement 2 is this is the only other notes lecture for this week. The other thing I have is the 2 reviews for Wednesday and Thursday. And I don't plan on doing lectures for the reviews. Because if I'm taking away those homeworks, and there aren't that many problems on these for you to practice, I'll make sure you get as much practice as possible. If you have issues, post on the discussion board, but I don't plan on doing lectures for the reviews. As you can tell, this week, my setup is like a little more snazzy than the document camera with all my new tools. And I got my, fun story. I am using OBS, Open Broadcast software to do these recordings. This is version 25.0.4. And if you ever watch streams of people on YouTube or Twitch or anything, this is a very common piece of software to use. It's totally free. Right now it's set to capture my screen. And so what it's doing is it's capturing my screen. Well, what's in my screen? Well, OBS is on my screen. Well, OBS shows my screen, which has OBS inside of it, which has my screen inside of it, which has OBS inside of it, which has my screen. You can see like very, very small versions of the mouse moving around because it's like looped within itself. And you can see down here, here's my audio capture, like if I'm totally quiet. See the bar went down. As I talk, it goes back up. And my microphone's really good. You could even pick up the clicks of my mouse like this. Can I get it to red? It's actually, there we go. That's better. I got it there. Anyway, I used to do some streaming on YouTube, make some videos, and but I did it like 5 years ago. And fun story, I had to update OBS because I haven't done it in 5 years. I want the latest version. Well, when I was streaming, the version was 0.67. So more than 25 full versions later, here we are at OBS 25.0.4. So that's pretty entertaining. I don't remember if I mentioned this in the last lecture, but from last week, only like 3 people did the extra homeworks. So I don't plan on posting the extra assignments for homework. If you want extra practice, I really just strongly recommend going to Khan Academy. Khan Academy has all the same stuff we're doing. For graphing, it's not quite as thorough because you don't get to draw the graph. If you go through all the reviews and you're feeling uncertain and you want more, feel free to post on the discussion board and I'll add an extra optional review for people to do. It won't be for a grade. I feel like it's enough, but if you feel like it's not enough and you're not confident, you want more practice, just let me know and I'll go ahead and I'll post something extra there. If you don't want to out yourself as the person who wants more work, you can go ahead and send that in an email too. Okay? By the way, as you can see, my microphone works really well. My webcam does too. And I spent like 3 hours today with customer service for a website. Because, my school, I do distance learning. And normally I go to my public library to proctor my exams. And the public libraries are all closed. So I don't have any proctors for my exams. Well, there's a service called ProctorU. And ProctorU, they like take over your webcam and your microphone to make sure no one's talking or in the room with you, and you have to pay for it. I have to pay for someone to invade my privacy like this. And they even wanted to install software that would let them remotely access my computer and click around on my screen and everything. Was not super happy with these people, but I had to do it for my classes, right? Well, I go on the website and it can't detect my webcam or a microphone. It says I don't have a microphone plugged in. Hey guys, do I have a microphone plugged in? Yeah, I have a microphone plugged in. You can hear it because I'm recording right now. So these people spend like 3 hours and they convinced me I give them control of my computer because what else am I going to do, right? Not take the test? And what do they tell me? They mess up so many settings on my computer and then they tell me, yeah, your microphone doesn't work. And they told me to go to an Apple store to get it fixed. 1, all the malls and everything are probably closed, right? Apple store is probably not open, I hope. 2, I'm not on a frickin' Apple, okay? This is a PC. So they're so incompetent, they didn't even know what kind of computer I was using. Anyway, I was lucky. I emailed my professor, and he offered to proctor me personally by connecting with me on Zoom. So props to Dr. Warely for being a bro. All right, that's 8 minutes before I started the content. Almost 9, right? So let's get to it. Okay. And there's my magic eye. Let's get that back up there. Okay. So a rational function looks like f of x equals p of x over q of x. And this is completely inconsequential, okay? This is like not helpful at all. It's not like the standard form of the reciprocal function where the standard form gave you information about its transformations. Now this is just totally a formality and totally useless, okay? But there it is. We filled in that box. Good job for us. But what we want to know is that what we want to say is p and x and qx are both polynomials. I want to assume you're listening to this while also filling it and using the cheat key because you got tired of me. We'll find out. And, there's a rule, right? Q of x, we can't divide by 0. So q of x cannot be 0. Okay? And so these are both going to be polynomials, top and bottom. And we're going to do some things. We're going to simplify. Okay, we're going to find the x-intercepts by setting the numerator equal to 0. That's not actually how I do it. I set by setting, it makes sense to me at least, to say f of x equal to 0. And it's effectively the same thing, but it's more logical to me because, right, when you have an x-intercept, we know an x-intercept. At an x-intercept, y equals 0. So if I set f of x is equal to y, right, same thing. If I set that equal to 0, that's the same thing as finding the x-intercept. Whereas setting the numerator equal to 0, it's like, well, why am I setting the numerator equal to 0? I don't know. Mr. Dufresne told me to in his lecture notes. He tells me to do all kinds of crazy stuff, and I do it. So that's just how math works. We find the vertical asymptotes by setting the denominator equal to 0. That's just like the reciprocals we did with 8.6. Now, the horizontal asymptote is a pain in the butt. Okay, let's talk about this. I was gonna say you guys got all this down, but it doesn't matter because you can pause the video. Okay, let's talk about horizontal asymptotes. Oh, I made the see the dot moved it again? That's me trying to scroll up. This one. And let's go and kick that magic eye right there. And you know, I don't even. And let's talk about these horizontal asymptotes. Okay. So there are three. Remember, our function is, I'm right up here, f of x equals p of x over q of x, right? And when we actually have these functions, you know, sometimes the numerator has more going on than the denominator, and sometimes the denominator has more going on than the numerator. When we say the degree of p, we're talking about what is the degree of this polynomial. And if the degree of the polynomial on top is bigger than the degree of the polynomial on the bottom, then there's actually no horizontal asymptote. No horizontal asymptote. So let me give you an example of that, okay? If I have f of x equal to x squared minus 1 over x plus 1, okay? This actually has no horizontal asymptote. Why? Because my degree of p, remember my numerator here is p. This is, right, numerator p. Here's my numerator p. Well, my degree of that is 2. And so that's my degree of p. The more circles I add in different colors, the more you understand it, right? And just like class. And for q of x, that's my denominator. Wow, that doesn't show up well. Let's try orange, which is the grossest color. God, looks like ketchup mixed with mustard. All right, so q of x. Here's my q of x. And remember, there's an invisible 1 right here on this x. So what's my degree of, I'm running low on different colors. What's my degree of this? Let's do light blue. My degree here is 1. And that's q, right? This is q of x. So my degree of q. So in other words, what I'm saying is 1, that's the degree of q, right? Remember, in case you forgot, degree is the highest exponent of a polynomial. And my degree here is 2. So 2 is greater than 1, right? This exponent right here is greater than this exponent down here. In that case, there's no horizontal asymptote. Okay, so that's situation 1. Situation 2, if the degree of p is less than degree of q, then the horizontal asymptote is y equals 0. So that would be if we have something like let's just flip this fraction actually. F of x equals x plus 1 over, I feel like my handwriting is getting really good, x squared minus 1, okay? So my numerator is, this is p up here, and this has an invisible 1. So let's circle it again. This is 1 for my p. And my q has a degree of 2. So if my numerator degree is less than my denominator degree, then the horizontal asymptote is y equals 0. Okay? Last situation, what if the degree of p is equal to the degree of q? So I'll do that with a situation like f of x equals, let's do 8x squared plus 3x minus 5 over x squared plus x plus 10. Okay? So in this situation, what are the degrees? My degree of p is 2. And my degree of q is 2. So the degree is the same? Yes. And in this case, this is the weird one. Well, they're all weird. Everything's weird in math. The horizontal asymptote is y equal to the leading, I'll say lead, coefficient of p of x divided by the lead coefficient of q of x. So what is that? This is might be confusing for you. What does it mean in practice? Well, what's our leading coefficient? The leading coefficient is the coefficient of our highest degree term of the polynomial. What's that mean? Well, here's our, let's do it in red. Here's my polynomial. Okay. Here's one of them. Here's p of q. My p of x polynomial. I have 3 terms, -5, 3x, and 8x squared. The one with the highest degree, which is 8x squared, this right here is my leading term, this 8x squared. So the leading coefficient is just the coefficient of that leading term. So in other words, I'm trying to figure out the right color. In other words, it's 8. Okay, this is my leading coefficient. And by the same logic, the leading coefficient of the denominator of q of x is the invisible 1 right here. So what is the leading coefficient of p of x divided by the leading coefficient of q of x? Well, that's 8 divided by 1, which is 8. So this right here has a horizontal asymptote at y equals 8. Okay? That's okay if it's a little confusing to you. You have to do some practice problems. I think the hardest thing is just keeping these rules straight, okay? Hopefully, I think this one right here, the first one, will make sense once I do problem number 3 with you guys. Hopefully this second one makes sense to you, because once you reduce the fraction, if the bottom degree is larger, then you just have a reciprocal function, like in the last lesson, which have, by default, an asymptote at y equals 0, right? If there's no k value. And you'll notice that with f of x equals p of x over q of x, there is no plus k over here, right? There's nothing over here. So we don't, if this simplifies to a fraction, there's nothing over here to shift it up. It's just a reciprocal function without any vertical shifts, which puts the horizontal asymptote at y equals 0. This is a really good skill to have for calculus, okay? So let's destroy everything. It's like Space Invaders, but not as fun. I actually once made a game over the summer in Unity, which is a programming language for making video games, where you were a little spaceship going around shooting other spaceships. It's pretty good. Pretty good. Okay, let's go down here. And we've got holes. Holes in the function. What's a hole? Okay, so holes are breaks in the graph, but they're not asymptotes, okay? So you guys know asymptotes are no-no zones on graphs, right? If there's an asymptote somewhere, you can't, like if there's an asymptote at x equals 4, that asymptote at x equals 4 means that you can't have an x equals 4 value, right? Well, a hole is the same thing, except it doesn't, what makes something an asymptote is that the values around it approach that point asymptotically, right? So like in our previous graphs, for example, if something this is my my coordinate plane, and I had a graph that approached 0 asymptotically, right? It got like really close to 0, but it never hit. That's part of there being an asymptote right here at y equals 0 while I mess up my entire graph. A hole doesn't have that feature. It doesn't have anything that's being approached asymptotically. There's just a missing value in the graph, okay? And I'll give you guys an example of that with number 3. And holes exist when you can simplify the function, okay? When something in p of x over q of x can be factored out and cancels, okay? And I'll give you guys an example of that. Well, there's my dot again moving. I've got to stop doing that. All right, so let's erase my crap. And let's go down to number 1. Let's do this problem. So first, what do I notice? Let's go down the list of features. I really think going down the feature list is a really good idea on these problems before you do any graphing, okay? So first, what's the x-intercept? Remember, an x-intercept occurs when y equals 0. So let me show you my logic here of why I think this is a good way to think of it. For an x-intercept, y equals 0, right? Because it's hitting the x-axis. If it's hitting the x-axis down here, y must be 0. Well, if that's the case, let's set this equal to 0. 0 equals x minus 4 over x plus 4. Now, I know right now you're thinking like that looks really confusing. But this is a really easy equation to solve if you use a little trick, right? We want to solve for x. Remember, I always told you if you have x in the denominator, you need to get x out of the denominator. So what am I going to do? I'm going to multiply both sides of this equation by x plus 4. So I multiply the right side by x plus 4 and the left side by x plus 4 in tiny crooked diagonal numbers. Well, what happens on the right side? X plus 4 and x plus 4 cancels. What happens on the left side? What is x plus 4 times 0? Isn't that 0? Yeah, it is. So now I just have 0 equals x minus 4. Basically, I can just get rid of this whole thing, right? Now I'm solving for x, add 4 to both sides, and I just get x equals 4. Wasn't that easy? I know it seems like a lot, but you can do this in your head. make this f of x equal to 0, get rid of the denominator because you multiply this and it's times 0. 0 equals x minus 4. Now, what is this the same thing as? Isn't it the same thing as saying the numerator equal to 0? And remember I told you up here, one of the rules was find the x-intercepts by setting the numerator equal to 0. And I told you, I think it's better to set f of x equal to 0, but really it's the same thing. What is the same thing? Because once you set f of x equal to 0, it eliminates the denominator, and you have the numerator equal to 0. But there's no intuition there, you know? It's really important to build intuition. So I'm going to erase. This is a horrible mess. What a terrible night for a curse. Okay. And let's, ooh, I don't like this. It's like, okay, it's something with that line being too high up. That's not bad. I can deal. I can deal. All right. So what's my x-intercept? When y was equal to 0, and I'll delete this over here. When y was equal to 0, it turns out that x equals 4, right? So my x-intercept is what? It's 4, 0. Not bad, right? Vertical asymptote. The vertical asymptote, remember, is the same as before. The vertical asymptote occurs when we're going to be dividing by 0. So we want x plus 4 to equal to 0. What x value is that? That's when x is negative 4. So I still have a vertical asymptote at x equals negative 4. And now for the horizontal asymptote, let's go back up to our rules up here. For horizontal asymptote, what's our situation? Is the degree of p greater than degree of q? Is p less than q, or is p equal to q? Well, here's my p, here's my q. They both have a degree of 1. So I have a degree of p equal to degree of q situation, which means my horizontal asymptote is at the lead coefficients divided. What are the lead coefficients? Well, it's 1 here and 1 here, right? Right, we've got 1 here and 1 here. So it's my horizontal asymptote. It's 1 divided by 1, or y equal to 1. Okay? Holes only occur when we can simplify by dividing things in the numerator and denominator. I can't divide these right evenly, so there are no holes. No holes in the first problem. Which I don't know, something about holes and graphing is like, I don't know. When you discover one, it's kind of neat. It's like a pocket of treasure or something. Okay, so let's go ahead and graph this thing. Okay, let's do some values. X, f of x, and again, what can't I have? X equals negative 4 is not okay. So let's do some points around it. Let's do x is negative 5, x is negative 3, x is negative 2, x is negative 6. Let's do the math for those. If x is negative 6, I'm going to get rid of these ones. I'm finding them very distracting. If x is negative 6 minus 4 is negative 10. Negative 6 plus 4 is negative 2. So I have negative 10 over negative 2, which is positive 5. If I have negative 5 minus 4 is negative 9. Negative 5 plus 4 is negative 1. So I have negative 9 over negative 1, which is positive 9. If x is negative 3 minus 4 is negative 7. Negative 3 plus 4 is 1. So I have negative 7 over 1, which is negative 7. If x is negative 2 minus 4 is negative 6. Negative 2 plus 4 is 2. So I have negative 6 over 2, which is negative 3. Let's go ahead and take a second and graph these values before we move on, huh? So I have negative 6, 5. There's negative 5. Negative 6, 5. 1, 2, 3, 4, 5. Yeah. There's negative 6, 5. Negative 5, 9. Negative 5, 9. And I have negative 3, negative 7. Negative 3, negative 7. Negative 2, negative 3. Negative 2, negative 3. Huh. That looks weird, doesn't it? Like, that doesn't look like our other graphs. Well, I think if we include our asymptotes, it'll help us understand what we're really looking at here. So in green again here, I'm going to include our asymptotes. X equals negative 4 is our vertical asymptote. So here's x is negative 4. And let's draw on that vertical asymptote right here. And y equals 1 is the horizontal asymptote. Here's y equals 1. Now, I hope you get some kind of idea of what this looks like. It's going to look like this. It's going to curve like here on the bottom right. It's going to curve like this on the top left. Okay, so the asymptotes are important because when you're graphing rational functions and reciprocal functions, the line never passes the asymptotes. So the asymptotes, you know, these look like 4 random dots. I mean, maybe it's like a cubic function where it goes up and down and up again. Who knows what we're dealing with? But the asymptotes let us know, oh, you know, the graph can't pass the asymptotes. So once we have that, we've got something good. And now we also know what other values we want to check, right? I really want to see what things look like going over here. So that's x is negative 7. We'll do x is negative 7. And I also want to know what things look like over here. X equals negative 1. So we'll do x is negative 1. And heck, you know, let's do x is 0 too. Let's get it fancy. And then I also want to do x is negative 3.5 to see how things are trending down here. So let's do x is negative 3.5. And then I also want to see how things look up here. Now, you know, I don't think I want to look up here because I think it's pretty obvious by how things are going that like negative 4.5 is going to be way off the graph up here, right? Yeah, it's going to be. It's going to get ugly. So I won't do it. It's like way up here. But let's do some math here. Negative 7. Well, if I have negative 7 minus 4 is negative 11. Negative 7 plus 4 is negative 3. So I have negative 11 thirds, which is just, negative 11 over negative 3, which is positive 11 thirds, which is also, by the way, the same thing as 3 and 2 thirds. And again, I'm going to star that one, so I'm going to graph it later. If x is negative 1, negative 1 minus 4 is negative 5. Negative 1 plus 4 is 3. So I have negative 5 thirds, which is the same thing as negative 1 and 2 thirds. 0, one of my favorite numbers, 0 minus 4 is negative 4. 0 plus 4 is 4, so I have negative 4 over 4, which is negative 1. That's why I included it, because I knew it was going to be clean. Negative 3.5. Negative 3.5 minus 4 is negative 7.5. And negative 3.5 plus 4 is 0.5. So what I have here is, for negative 3.5, negative 7.5 divided by 0.5 is negative 15. Yeah, so that's going to be like star, star, star. Let's remember to, yeah, let's pretend that one's a star, okay? So negative 7 and 11 thirds. Negative 7 and 11 thirds, 3 and 2 thirds. So here's 1, 2, 3 and 2 thirds. Okay. Then I have negative 1 and 2 thirds. So negative 1 and 2 thirds. And then I have 0, negative 1. And then I have negative 3.5, negative 15. Negative 3.5, negative 15. That's like way down. It's, you know, I shouldn't have done that point just like, because that's like the same thing up here, right? It's like way up here. Okay. And if I do some more points, like if I do like x equals, let's look some more. Let's do some more points that kind of flesh this out over here. I don't like having this much empty space. What's good? X is 2. Let's do x is 2. That's a good one. If x is 2, 2 minus 4 is negative 2, and 2 plus 4 is 6. So I get negative 2 over 6, or negative 1/3. So when x is 2, this is negative 1/3. X is 2, f of x is negative 1/3. And let's do, what if I do 10? Just as high as we can go. Let's do 10. If I have 10, 10 minus 4 is 6. And then 6 over 14, right? I have 6/14, which is 3/7. So you see, we're getting close to that 1, right? At 10, we're at 3/7, which is like, you know, it's about half. Let's just call it. Okay, so it gets there. It takes longer sometimes. Okay, so I connect all these lines. There's my graph. Because I'm no way I'm gonna do these over here. Just too lazy right now. So domain and range. Remember, use the special notation x such that x is not, what can't x be? It can't be negative 4. Okay, x can be anything else. Y such that y cannot be, what can't y be? It can't be 1. So y cannot be 1. Okay, so that's our first completed problem, which took longer than I thought. How long did that take me? 37 minutes? Oh god. Well, you know. I got nothing. That took so long. Okay, well, anyway, that's one problem. It's my mouse handwriting. It takes so long, I think. Okay. And let's go on down. I said I want to do number 1. And let's do number 3. Number 3 is really easy, okay? But it demonstrates an important point. So if I have f of x equals x squared minus 1 over x minus 1, well, can't I factor this? And so now I have f of x equal to x plus 1, x minus 1 over x minus 1. And don't these cancel? And so now I just have f of x equal to x plus 1. That's not even a tricky graph, right? Like if I make a function table for this, x, f of x, and I say, like, oh, x is negative, let's start with negative 2. Negative 2, negative 1, 0, 1, 2. And if I plot these points, I have, oh, I didn't actually finish filling it out. If x is negative 2, negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1, 2, 3, right? So I have negative 2, negative 1. Negative 2, negative 1. Negative 1, 0. 0, 1. 1, 2. 2, 3. And, you know, this one's an outcast, deleted. And I got a line. Is that easy? I mean, it's easy. It's easy. Oh, wow. Okay, it's not easy to draw lines with a mouse. Yeah, it's like, let's pretend that's a line, okay. Are we done? No, we did it wrong. Guys, you're supposed to catch that, okay? It's okay. I'm here to save you. I'm here to save you. Well, what did I tell you before? I told you about something called holes, right? And I said, what's a hole? Well, a hole exists when you have a common factor between the numerator and denominator. In other words, that when something cancels, right? Do we have something cancel here? Yeah. Right? Yeah. Okay, cool. Do we have something cancel? Yeah, we had x minus 1 cancel. Huh. What do we do with that? Well, that's our hole. So when graphing this, at the point 1, 2, that would be there, okay, we don't include this point. Actually, it's going to ruin the whole line. So I'm going to, in blue, I'm going to put a circle here. This point does not exist. There's a hole there, okay? So what this means is this is a line, okay? And going from negative infinity up to this hole, I have points all the way, okay? At the hole, which only occurs at 1, 2, there's nothing, okay? 1.1, there's a value. 1.0001, there's a value. 0.9999, there's a value. Only specifically at 1, 2, is there no value. And notice, this 1, this x equals 1, also takes care of this right here. The asymptote, okay? There is no asymptote. So holes replace asymptotes. If you have a hole, there's no asymptote, okay? So let's fill out our information here. What's the x-intercept? 0, 1, right? Or sorry, negative 1, 0, I meant to say. You can just look at it because we graphed it. What's the vertical asymptote? There isn't one. What's the horizontal asymptote? There isn't one. Right? This is a line. Lines don't have asymptotes. Where's the hole? There's a hole at 1, 2. So what values can we, what's our domain? Still, use this notation. X such that x is not, what can't x be? Well, we can't have a frickin' hole, right? Can't have a value on the hole, so x cannot be 1. What's the range? The range is y such that y cannot be what? Well, if the hole is at x equals 1, y equals 2. So y can't be 2. Okay? So you might see lines on the test, right? This, you wouldn't look at this right here and say, oh yeah, that's a line. But it is. It's just a line with a hole in it. Line with a hole sounds like a really good band name. One of you guys should take advantage of that. Okay, let's delete this. And let's do, I was going to do 4 and 8, but it's taking me, wait, where's 8? Why don't I have an 8? Oh, I didn't include 8 in this. Oh my gosh, I got to fix the assignment. Well, I'm going to do number 4, and I'll leave number 8 for you guys because I forgot to copy it over to the assignment. I only did 2 pages out of 3. So there's a third page, okay? There's a third page. So let's do this problem right here. Step 1, let's factor. So what does this factor into? F of x equals x plus 5 over, maybe I'll flash to 8 on the answer key and just talk about it with you guys to make sure that we're all on the same page, because I think it is an important example. And x squared plus 9x plus 20 factors to x plus 4, x plus 5. Okay. Can something cancel? Absolutely. X plus 5 and x plus 5 can cancel. So what do I have now? It's just f of x equals 1 over x plus 4. Look, that's a reciprocal function, right? This is tricky now, okay? This is tricky. Does this have an asymptote? Yes, right? This has a vertical asymptote at x equals -4. So I have a vertical asymptote at x equals -4. I also have a hole, right? Because I canceled something. Where's the hole? At x equals -5, right? Whatever makes this 0, that's the hole. So if x is -5, -5 plus 5 is 0. There's my hole. So my hole is at -5, comma, and now where's the other part of the hole? Well, it's whatever would be there, okay? So these would cancel, and if this is -5, like if x is -5, what's this? So it's 1 over -5 plus 4. -5 plus 4 is -1. 1 over -1 is -1. So -5, -1, there's a hole. Horizontal asymptote. Well, what's our situation here? We have a larger degree in the bottom. So our Q is bigger than our P, or so our P is less than our Q in degrees. So if we have P is less than Q in degrees, then we have one at y equals 0. Right? And that should make sense because this is a reciprocal function that we talked about 8.6, right? And there's no k value here. So the default is y equals 0. So that means we've got a weird domain here, right? Or rather a complicated domain. X such that x is not, well, what's x not? It's not -4, right? We've got a vertical asymptote at x equals -4, so it's not -4. And also, we have a hole at x equals -5. So there are actually two values that x cannot be. And this is why it's nice to use this notation, because if you used the parentheses where you list the values that x can be, it would be a little messier, right? It would be, my domain would look like -infinity to -4, comma, -4 to -5, comma, -5 to infinity. So what would you rather write? Would you rather write this for the domain or this? I like this much more. Just list the two exceptions, which we already found, right? We already found the exceptions, so it's not any extra thinking just to list the exceptions, and you're done. Range, wow. Okay. Time for Dufresne to go to the mental word if he's drawing braces like that. Y is such that y is not, and what y values can we have? Well, we have a hole at y equals -1, and we have a horizontal asymptote at y equals 0. So two things y can't be, right? So now to graph this, let's do our function table. X, f of x. And again, when picking our x values, we want to think about the asymptote. Don't think about the hole, okay? Think about the asymptote. And we know we have a hole at -5, -1. I'll put that in there. But we want to pick things around x equals -4. So naturally, I do want to put -5, -1 in there. Let's do it in red to remind ourselves that, or let's do it in orange to remind ourselves that -5, -1 is a hole. Okay, it's no good. And let's check something. Let's check -6. Let's check -3, -2. Let's do -1, and let's do like -7, -8. I'm just listing numbers now. Okay, let's see what these things look like. So if I have -3, -3 plus 4 is 1. 1 over 1 is 1, so this is 1. If it's -2, -2 plus 4 is 2, so it's 1/2, or 0.5. If it's -1, -1 plus 4 is 3, so this is 1/3. -6, -6 plus 4 is -2, so this is -0.5. -7, -7 plus 4 is -1. This is going to be -1/3. And it's -8, right? It'll be -1/4, which probably isn't necessary. So let's mark these points, which wow, that was really bad for, but we're gonna let it go. Let's rock it. -3, 1. I always start with a nice whole number. -3, 1 makes me feel safe. -2, 0.5. -2, 0.5. -1, 1/3. -6, -1/2. So I have -5, -6, -1/2. -7, -1/3. So -7, -1/3. I should like put this one a little down more, but it's pretty hard to be exact. -8, -1/4. Wow, it's almost looking like it's going up. I'm doing a bad job. Okay, I had to. That's unacceptable. That's better. Okay, and now let's not forget we have a whole, right? The whole is at -5, -1. Here's -5, -1. Here's my whole. And if I put on my asymptotes, hopefully this becomes more clear what we're dealing with here. My vertical asymptote is x equals -4. So here's my -4 asymptote. Let's pretend it's on the line, right? Yeah, it looks, wow, crap. No, you're bad. You don't get to live. You're not fit. Okay. And then this is like not showing up enough. There we go. It looks better to me. And then y equals 0 is our horizontal asymptote. Boom. And now look, it's clear it's going on, right? It's going to go and so why isn't it curving up enough? Well, it's 1 over x plus 4, so really we'd want to do some things around this, around the 0 in the denominator. So I think it'd be really good if we did a -3.5 and a -4.5. If this is -3.5, -3.5 plus 4 is 0.5. 1 over 0.5 is 2. And -4.5 plus 4 is -0.5. 1 over -0.5 is -2. So we have two nice new values to plot here. That'll help give shape to this. -3.52, -3.52, and -4.5, -2. -4.5. Wait, hold on. -4.5, -2. Okay. So now I think the shape's really clear with the asymptotes. Okay, let's draw this in. And just, you want to make sure that your hole is really clear here, okay? Gotta pay the troll toll. Last part, X-Intercept. What's the X-Intercept? Well, it's when y equals 0, right? So, because we have a horizontal asymptote at y equals 0, there is no x-intercept, right? This never hits the x-axis. So this is NA. Let's just make it in blue, huh? Just make it blue. Now, if you had thought of the x-intercept just by setting the numerator equal to 0, right, you wouldn't have got NA for the x-intercept. So you have to kind of play it by ear. So it's never wrong to graph first, okay? But it's good to look at asymptotes to help guide your graph. Okay, so that's number 4. You guys are doing good with this? I know it's a lot of information, especially the rules about horizontal asymptotes. You feeling good? Really? Well, that's okay. I mean, you've still got the reviews to practice, and you can always ask me questions, if you get stuck. I'm here for you. So if you're not feeling good, that's okay. Like I said, I don't have the problem 8, so let me pull up the is this it? No. Wait, no. Wrong. Let's see. Let's put up 8.7 key. Okay, and I'll just talk about it for a second, and okay. So what I wanted to draw your attention to on this one is when you factor it, it looks like this. Oh, I should probably pull up my magic eye thingy. Okay. So we factor it, and can I Control Z that? No, I can't. There's no undo button for this. That's okay. It's free. I'm not going to complain about free. So my x plus 7's cancel, and I have x minus 4 over x plus 5, right? So I know that I have a vertical asymptote when x equals -5. There's my vertical asymptote. So here's x is -5. I make my vertical asymptote. That's going to help guide me. And my horizontal asymptote at y equals 1. And why do I know it's 1? Because these degrees are both the same, right? They're both, I shouldn't put a 0. They're both 1. And they both have coefficients of 1. 1 over 1 is 1. So that's my horizontal asymptote, which is right here. Okay. And then we have a hole at -7. But you still have to know where that hole is, so you got to plug. When you know that the hole is at -7, you have to plug that x equals -7 into here still to figure out what the y value is, which is 5.5. And now, so when we're listing what ranges don't work, we know the y equals 1 doesn't work, which is listed right here. And we know that y equals 5.5 doesn't work from the hole, which is listed right here. The vertical asymptote from x equals -5 is listed right here for the domain as not working. And for the hole, x equals -7 doesn't work, which is right here. Okay, and then the rest is just function tables. For the y-intercept, set y equal to 0 and solve this, which again is not as hard as you think, because when you multiply this entire part times 0, you just get 0 equals x squared plus 3x minus 28. And if you factor that, that's x plus 7, x minus 4. And so we already know there's a hole at x equals -7, right? So that's not going to be our x-intercept. It's going to be when x equals 4 from this one. And if you find that thought process confusing, that's okay. What I recommend on the test with the x-intercepts is to just make the function table and start plugging through things, and that'd make it clear, right? If you're graphing this, because we have a hole at -7, 5.5. Here's my hole at -7, 5.5. you're not going to, once you graph that hole, you're not under any thought that this x equals -7 could possibly be the x-intercept, right? So that solves that. I think that's all I got for this week. If I have anything else, I'll post it on eCampus. I'll have the test up probably within a couple days. I want to make sure that it's completed. I know I finished my questions, but I don't know if the other teachers have made theirs. Yep, that's all I got. Have a great night, guys, or a great day, or a great morning, or a great whenever you're watching this, have a good one. Or if you're not watching it, well, I'm not talking to you then, am I? No, I'm not. I'm not speaking to you. I'm only speaking to the viewers.